Hey guys, it's Arihant from Witness, and today we're going to tackle a problem in MATLAB. So the question we have is how do we find the maximum and minimum values of a function in MATLAB? So let's get started. The first thing we need to do is we need to declare the variables that we're going to use. In this case, we just need one variable, so I'm going to declare x. We do this by using the syms command. So I do syms, and the system knows that I'm going to use a variable called x. The next thing we need to do is we need to write our function. The function we're using in this case is x cubed minus 12x minus 5. So we've done that, and we need to declare the interval in which we will be finding the maximum and minimum values. In this case, we have it as from minus 4 till 4. Now that I've done that, I'm going to run this once just to make sure everything is all right. And as you can see in the workspace, we have a variable x, we have an interval I, which is values from minus 4 to 4, and we have a function. The next thing I'm going to do is I'm going to create two more variables called a and b, and these two variables are just going to make my job a little bit easier. I'm going to give them values I1, and I'm going to give b the value I2. So as I run this, you can see that A has minus 4 and B has 4. What this expression does is that it will assign A the value, which is the first value in this expression, which is minus 4, and I2 will assign the second value in this expression, which is 4. So anytime I want to use these starting and end points, I don't have to write my I of I1 and I2. I can just write A and B. The next thing I'm going to do is I'm going to use the linspace command. What the linspace command does is that it'll take two start points and end points and then the number of intervals, and it's going to create a set of values from the start point till the end point, and the total number of values will be the number of intervals that we specify. Let's take an example. Let's say I take 0 and 5 as my start point and end points, and I give the number of intervals as 10. I do that and I run the code, and then in my command window I type in t. As you see, we have 10 values from 0 till 5. So that is essentially what linspace does. So next I'm going to create another set of values called g, and g is going to store all of the values that we get when we input the values of t into this function f of x. So I'm going to do double f of t. Double is a data type that holds a large range of values, so that's why we're using it. Don't pay much attention to it. This is the main thing that you guys need to focus on. F of t will hold all of the values we get when we input t into f of x, and it stores them in g. So let me run this, and as you can see, g has this set of values. Um, t has 0, 0.55, 1.11, and t has all of these values that we get when we input these values into f of x. For this case, we're going to have t from a to b, and then the intervals will be 10,000. So t will hold values from minus 4 till 4, and it's going to have 10,000 intervals, and g is going to have the results of all of those 10,000 intervals when they're plugged into f of x. Let's run this once to see the values updated, and yeah, they have done that. The next thing I'm going to do is I'm going to create an Imax variable, and I'm going to use the find peaks function. So what I mean by that is I'm going to use a function to find the maximum value in this set G. So G has 10,000 values, and I'm going to find the highest or the maximum value by using this command. The way we do that is we put square brackets, Imax, this is the name of the variable you want to give, LOC, sorry for that, LOC equals to find peaks G. Now that we've done that, Imax will have the maximum value of G. So there you go. The maximum value is 11 and the location in this set is 2501. The next thing I'm going to do is I'm going to create another value. I'm going to create Imax underscore L. L is going to stand for location. You can give this any name. I've just chosen to do this. And I'm going to do round T of LOC, comma 4. And we run it. I'm going to explain what that means in just a minute. Yeah. So as you can see, Imax L is minus 1.998. So the location we had, the value we had in LOC was 2501. In this case, when we do T of LOC, we're going to plug in this value into this set so that we find the exact value that we want from the interval. It's going to sound a bit confusing, but just try to understand that T is our x-axis and this location is finding it in terms of this. So when we get the index value of G in LOC, we have to plug that in T so that the result gets correlated to its proper value. It's a bit confusing, but you'll get it with some practice. The next thing I'm going to do is we're going to now move on and find the minimum value of this function. And it's pretty simple. What we need to do is we need to create a new function f of x and simply assign it minus f of x. Because when we find the minimum value of a function, if we completely negate the function, so if we take f of x as minus x cubed plus 12x plus 5, and then we find the maximum value of that function, it'll be the minimum value of this function. So we take the negative, that is, we invert the graph, and then find the maximum value, the peak value, which will be the minimum value of our original function. I hope that's clear. And we don't need to do much more with this. We can use the same intervals, the same set of values, and we just need to do a couple of small things. So we've taken a variable g that's going to store all of the values that t has when we input it into f of x. Similarly, we'll create a set of values h, and h will hold all of the values we get when we input the value of t into f1 of x. So we've done the same thing here. We're going to create another variable I min, comma LOC. This is the syntax. And we're going to do find peaks of h the way we did find peaks of g. We're going to do find peaks of h for this particular function. And then I'm going to create a variable imin underscore location and round t of LOC, comma 4. Same thing we did here. Now when I run this in our workspace, I'm getting a small error. Error in question 1, line 2. What is this error? Yeah, I accidentally gave it f of x. This needs to be f of t. Just make sure you're putting the variables right. That was a rookie error on my part. So f of t, and now when we run it, it should work. So there we go. We see that we've got our results in our workspace. The minimum value is 21 and the location is 1.998. So you may wonder that the minimum value is 21 and the maximum value is 11. How does that work? So the minimum value should actually be minus 21. This I min holds the modulus of that value. So when we have to display these values, we're going to have to correct that. And the way we're going to do that is we're going to reach that in just a bit. I'm going to clear my command window. And now that we have all of our values, we need to display them. And we're going to make the necessary correction that I just talked about. So I use the display command, which is disp bracket, and then in single quotes, we type whatever we need to. I'm going to put in local maximum occurs at x equals to, and then this gonna put in imax underscore location because imax underscore l holds the location. Gonna copy this. I'm gonna do the same thing for minimum. Minimum occurs at x equals to, and then I'm gonna change imax to imin because for me imin underscore l holds the maximum, holds the minimum value, holds the location of the minimum value. I'm so sorry. It holds the location of the minimum value. And when I run this, we're gonna get a result. Yeah, maximum occurs at 1 minus 1.998, minimum occurs at 1.998. Clear my command window. And then now we're gonna print the maximum and minimum values. So this, and then maximum value will be, and what I'm gonna do here is in display, I'm gonna do double f of imax underscore l. So there. I'm so sorry. Um, yeah, so this double f of Imax L. So Imax L holds the location of the maximum value. So when I input that into the function f of x, we're going to get the maximum value. And in this case, it's going to be 11. But when we do that for minimum, it's going to show us minus 21. And if I just display Imin, it's going to show us 21. That is the reason we're going to do f of Imax L instead of just IMAX so that we don't have any errors related to the sign. So just gonna change this to minimum and this to IMIN, and hopefully we are good. Boom. So the local maximum occurs at minus 1.9998. The minimum occurs at 1.998. The maximum value is 11. The minimum value is minus 21. And as you notice that we're having four zeros here, that is because when we use the round function and we put in round t of LOC comma 4, it rounded whatever value this will give up to 4 places. The last thing we need to do is we need to plot the graph, and that's actually really simple. Not here. I'm gonna clear the command window again. All right, so the next thing we need to do, and the final thing that is we need to plot the graph, which is actually pretty simple. So we're going to use the plot function. We're going to do plot t and f of t. So remember when I told you that t will have the x-axis and f of t will have the y-axis? This is what I meant by that. So if we go back to g is double of f of t. This is what I meant. When we use the plot function, it's a good thing to write hold on and move on. This is a good practice to do that. So whenever you're using the plot function, just do that. And then we're going to plot Imax x as the, we're going to plot this particular point. We're going to mark this particular point. This is going to plot the whole graph, and this is going to mark a particular point. So plot Imax x and then f of Imax. Sorry, this is supposed to be Imax L. I got confused. Whatever your variable name that holds the location, and then this that holds the value. Right. This should be double. As I said, double is a data type that holds a large range of values, so it's always a good thing to use double. Now, what we're gonna do is when we draw or we plot this point, it's a good practice to mark that point so that it's clear. And the way we do that, the way I'm going to do it is I'm going to use OR. So what OR means, O will circle that point and R will circle that point red. So if I do OB or OG, it will circle that point with the color code that I give here. So the color code for red is R, so it's going to circle that point red. I'm going to do a similar thing. I'm just going to copy. I cut that, so sorry. I'm going to do the same thing with I'm in here, I'm in here, and for this, we're going to change it up a bit. We're going to do star G. So this is going to mark that point with a star and the color will be G. I hope that's clear. Finally, we do hold off and it should work. Let's run this. It's going to take some time. So the maximum values and the minimum values that we got before, that's right. And if you look at the graph, we've got this sweet, nice graph here. Um, if I go on this point, it's minus 1.99811, just as we got here. And this is 1.998 and minus 21, just as we got here. And because we put OR, it circled this in the color red. We put star G, it marked it with a star with the color green. So that was it. To just give you a quick recap, what we're going to do is we go over the process. If you remember the process, it will be very easy to solve this later. We declare a variable x, we write the function, we give the interval. This is all that's going to be given in the question. Now we declare two variables a and b. This is completely optional. If you want to do it, you do it. If you don't, you can skip this. I1, I2, so that a has the start point, b has the end point. T will hold the set of values from A to B and it will hold 10,000 intervals. G will hold the result of those 10,000 intervals when we put it into f of x. Imax will find the maximum value, Imax underscore L, when we do T of LOC will hold the index in the set T, which is going to be our x-axis in the future. So we need this value, not the value that we get in LOC. And yeah, we have that. We're going to do the same process to find the minimum value. We invert the function by creating a new function f1x and assigning it negative. Because when we flip this graph and we find the maximum of that graph, it will be the minimum of our original graph. We repeat the process. And when we get the value of imin through the find peaks function, we're going to get 21 here because it shows us the magnitude, not the actual value. So when we're displaying the results, we're gonna have to use f of I min underscore L and f of I max underscore L so that we get the sign and it also gets plotted the right way. Similarly, while plotting it, we need to use I max underscore L, I min underscore L, and then f of those values. OR and star G are the representations that we will get on our graph. And hey, that's it. Thank you so much for watching.